Hello friends, welcome to my channel. Today let's look at this Codility training problem. So here it says that we draw n disks on a plane, and the disks are numbered from 0 to n minus 1. And the radius of the disk is given, and the center of the disk is the index of A. For example, the jth disk is drawn with its center at J and 0, and the radius is A of J. So we want to count number of circles that are intersecting with each other. And here's additional detail. The function you wrote should return -1 if number of intersecting pairs exceeds 10 million. Okay. Also, array A can contain very large number, and this is a indication that we might want to use long for calculation instead of int. Okay, so how do we do that programmatically? How do we do that? So let's look at this example here. Okay. So as you can see that we have 3 circles, and another thing to notice here is that the first circle and the third circle, they're touching each other. So if they're touching each other, we also consider them as intersecting with each other. So with that, you should calculate. That the number of pairs of circles intersecting with each other is 3, right? So basically, you can see that the first circle is intersecting with the second circle, and the second circle is intersecting with the third circle. And also, because the first circle is touching the third circle, and we also consider them intersecting. So the first circle is intersecting with the third circle. So there are 3 pairs of circles intersecting with each other. So how do we calculate that programmatically? We do that by looking at the left end and the right end of each circle. Okay. So for example, we go from this direction from left to right, and so first we will encounter the first circle, right? So when we encounter the left side of the first circle, we want to record that by having a variable to record that. So let's call this variable present circles. Okay, right now it equals to 1 because we've encountered 1 circle, and this number is going to be reduced once we reach the end of a circle. So now we're here. We have encountered 1 circle. So the value of present circle is 1 at this point, and then we continue going in this direction, and now we have encountered the second circle, right? And we can increase this number from 1 to 2 because now we have 2 circles, and then we continue to go in this direction. Now we have 2 circles touching with each other, and we want to consider the beginning circle first. So at this point we have encountered 3 circles. That's all 3 circles that we encountered. And then at the same point, right? Because these 2 are touching with each other, and at the same point, we have also reached the end of the first circle, right? So the first circle is reaching its end. So here we are going to reduce this one by 1. Okay, so, and also we want to count number of pairs. count number of, so the count is number of pairs of circles intersecting with each other. And now we have reached the end of the first circle, and imagine in your head that we're removing this circle from this picture, but this circle is already intersecting with the second circle and the third circle, right? So with the first circle removed from here, and the number of circles intersecting with the removed circle, which is the first circle, is 2, right? So here we want to record 2 here. And then we continue going in this direction, and again we've reached the end of the second circle here, right? So here we're going to continue remove this or reduce this value by 1, which gives us just 1. Okay, just 1. And by removing this circle out of the picture, and we also have to record how many circles that this circle intersects, which is 1 circle, right? So this circle, before removing this circle from the picture, and this circle was intersecting with this circle, so we're gonna have to add 1 to the count here. Okay, and then we continue in this direction, and now we hit the end of the last circle, and we're going to again remove this circle, and that gives us 0 because this is the last circle standing here, and there are no circles left for it to intersect with. So the number of circles that this circle intersects is 0. And if we add all of them together, that gives us the correct number, count 3 here. Okay, so this is basically what we're going to do, the algorithm that we're going to implement. So let's go back to the problem here, and we're going to implement the algorithm that I just illustrated. So first I'm going to create a class. I'm going to call it data, and the public long value, and public int end. Okay. So here we use the long here because as you can see, the value of a elements in A could be very large. So to avoid overflow problem, and I define the type of value to long. And for the end, so this variable is what we use to indicate if this is the left end of a circle or right end of a circle. So here we can denote this. We use 1 to denote for the beginning of the circle, or left end of circle we use -1. Okay, for the end of circle, or right end of the circle. And next I'm going to define result and return result. Okay. And next I'm going to calculate all of the beginning point and end point of the circle. So I'm going to define list. So here I will need to import Java util. Okay, data points equals to new array list. Okay, and then I'm going to calculate them in a for loop. So this is just a regular for loop. Also, index I is very important for calculating because for calculating the left end and the right end of a circle, because these are the center of a circle. They represent centers of the circle. So left end value equals to, that's too long, equal to I minus a of I, and also the end equals to 1 because this is the left end, and also we need right end. So right end value equals to I plus a of I. We want to cast it to long. Also, its end should be -1. This is how we know which point is left end of a circle or right end of a circle. Now we're going to add the data points, so left end and right end. Okay. Next, we're going to sort. Okay. So points sort. I'm going to use the lambda for sorting A and B. Okay, and because we're dealing with a large number, so I'm going to be explicit when it comes for a value comparison. So what I'm going to do is to first see if either value so this is points, and I sort A and B. Why is this? Okay. So if a value is less than B value, I'm going to return -1. Else, if a value is incompatible with byte type in missing return value. Okay, so we will have return value. So if A's value is greater than B's value, because they are data, I want to return 1. Okay, else, that is if A equals to B or A's value equals to B, then we want to compare by the end. Okay, and we let B's end minus A's end, because if we have two circles intersecting with each other, we want to make sure that we consider the starting position before the end position. Otherwise, we will be subtracting a circle or removing a circle from the picture or calculation prematurely. So that's why we have this here. Okay. So this is sort, and then next we're going to count. Okay, so here I'm going to create a variable. I call it count left, and for all the data points from points, we want to see if the point is a left end of the circle or right end of the circle. So if it's left end of the circle, then we want to increase count left by 1. Otherwise, if P is right end of the circle, then we first want to record number of pairs of circles intersecting with the circle that we're going to remove. Okay, and then we reduce number of circles by 1. Okay, this is because we have encountered end of one circle, and we're going to remove that circle from calculation. And also we will have to check for this condition here, if function so if the number of intersecting pairs exceeds 10 million, we want to return -1. So that is if result is greater than this big number, 1 2 3 4 1 2. Okay, so this is 10 million. Then we want to return -1. Okay. Yeah. So the time complexity, we created a list, and so let's say if n equals to a the length, then the length of points would be 2 times n, right? And in big O notation, this is still big O of n. And so here is calculating for all the points, right? So this for loop is still big O of n. Okay, and the sort here, okay, sort here, and this is big O of n log n, because this is a comparison based sorting, and the time complexity is n log n. And this part for calculating, and we are going through all the points in the points array list only once. So this part is big O of n, right? And return result. So we have 1 big O of n, 2 big O of n, and the big O of this is little big O of n log n. So the time complexity T of n equals to big O of n log n plus 2 times big O of n, which is essentially just big O of n log n. Run the code. Submit. Evaluating 100%. Well, that's all for this video, and thanks very much for your time, and hope you have a nice day, and see you next time.